Hello students, this is Latif sir. Today I'll discuss about ICC class 10 chemistry. The topic is chemical bonding. Today I'll discuss about this is second chapter of this of class 10 chemistry, and today I'll discuss about what is chemical bond, different types of chemical bond and their properties. Okay. So first introduction. We know everyone wants stability. Similarly, atoms also want stability. Okay, but how they will become stable? To know this answer, you have to remember the electronic configuration of noble gas. Just go, uh, just go back in the first chapter, periodic table, and uh, check one, check once again the electronic configuration of noble gases. Here it is given. Noble gases, that is inert gases, group 18 elements. They have 8 electrons in their valence shell. Oh, noble gases, which are noble gases? Helium, neon, argon, krypton, xenon, and radon. Okay, these all elements have 8 electrons in their valence shell except helium. Yeah. And we know that these elements are most stable, that is non-reactive to each other. Okay, because they have complete or outermost orbital, electron field, complete orbital in their valence shell. Okay, so except helium, helium has two electron, that is duplet, and others all other inert gases have 8 electrons in their valence shell, that is octet field. Okay, so those elements having similar electronic configuration to the noble gas are more stable. Okay, so the most stable electronic configuration is one in which there are 8 electrons. The most stable electronic configuration is one in which there are 8 electrons in their valence shell in maximum case. In some cases, for uh, for for lithium, beryllium, boron, for this element, and hydrogen. Okay, the most stable electronic configuration is 2 electrons in their valence shell, but for others element, 8 electrons in their valence shell, you have to remember. Okay, so what is why atoms react? Because in maximum cases atoms don't have 8 electrons in their valence shell, that is they do not have octet field in their valence shell. That's why they are not uh, they are not stable. They are not in stable condition like noble gases. Okay, so cause of chemical combination is the tendency of element to acquire the nearest noble gas configuration in their outermost orbit and become stable. The cause of chemical combination, that is chemical reaction, is the tendency of elements to acquire the nearest noble gas configuration in their outermost orbit and become stable. And how they become stable? By redistribution of electrons, that is by gaining or releasing electrons from their valence shell. Okay, to get the electronic configuration of noble gas or inert gases. So during redistribution of electrons, a bond, that is bond means force of attraction, develops between the atoms which bind them together to form molecule. This bond is known as chemical bond. So what is a chemical bond? A chemical bond may be defined as the force of attraction. Yeah, chemical bond is the force of attraction between any two atoms in a molecule to maintain stability. There are three methods in which atoms can achieve their stable electronic configuration. There are three methods in which atoms can achieve a stable configuration. First, by transfer of one or more electron from one atom to the other to form an electrovalent or ionic bond. So first case is by transferring electrons, one or more electrons from their uh, from one atom to other to form an electrovalent or ionic compound. Second method is by sharing of electrons. First transfer of electrons, second sharing of electrons. To sharing of one or more or one, two, or three pairs of electrons between two atoms to form a chemical bond. a covalent bond or a molecular bond. So second case is sharing of electrons between two atoms. First case is transfer of electron from one atom to another atom. Okay. And third case, when the shared electron pairs are contributed by only one of the combining atom, the bond formed is known as coordinate bond or dative bond. In case of dative bond, transfer of electrons, here also transfer of electrons you can say, but the or sharing of electrons. When the shared electron pairs, two electrons are shared from one component only. Okay, generally a bond is formed between two component or two atoms. Huh. If both the atoms share electron, then the bond form is known as covalent bond. If one component transfer one or more electron to the other component, then the bond formed is called ionic bond or covalent coordinate ionic bond or e- electrovalent bond. And if one component of the combining atoms, one of the two combining atoms share two electrons, then the bond formed is known as coordinate or dative bond. So first you have to read first electrovalent bond or ionic bond. Ionic bond formed between two components I have already told. And in ionic bond, one component will release electron and other component will accept the electron to become 8 electrons in their valence shell. That is to become stable in a state. Okay. Atoms of so which elements are formed generally forms electrovalent compound? Generally metals and non-metals. Electrovalent bond forms between metals and non-metals. So let's see atoms of metallic element. We know that metals have one, two, or three valence electrons. One, two, or three valence electron. That's why they easily release one, two, or three electrons from their valence shell huh, to become stable to get a stable electronic configuration, that is 8 electrons in their valence shell. And we know that non-metals have generally group 16, 15, 16, 17, 8, 17 elements. Non-metals have 7, 6 or 5 electrons in their valence shell or outermost shell. That's why they want to get extra electron stable to become stable, that is 8 electrons in their valence shell. Huh. So after the transfer of electrons, both combining atoms acquires electronic configuration of the nearest inert gas. Huh. A metallic atom which lose electron because they have 1, 2 or 3 extra electron in their valence shell. After losing 1, 2 or 3 electrons from their valence shell, metals become positively charged ions, that is cation. And non-metals, they have 7, 6 or 5 electrons in their valence shell. They will easily accept electron to become stable, that is 8 electrons in their valence shell. And after accepting electron, non-metals form negatively charged ion, that is known as anion. So what is an ion? An ion is a charged particle which is formed due to gain or lose of one or more electrons. Generally, cations form uh, after releasing electron, and anion form after gaining electron. Okay. So a metallic element whose one atom easily lose electron, if one electron release, then the monopositive cation will form. If two electron release a metal, if a metal release two electron, then bipositive or bivalent positive cat ion or cation will form. Okay. And anion will accept electron to form anion. If a non-metal accept one electron, it will convert into monovalent electronegative ion. That is, here it is given that Na sodium easily release one electron to form so Na plus cation. Similarly, chlorine Cl easily accept one electron to form Cl minus ion. Now the cation and anion being oppositely charged, that's why they attract each other and form a chemical bond. Since this chemical bond formation is due to the electrostatic force of attraction between a cation and anion, it is called electrovalent or ionic bond. First, in case of ionic bond formation, first metal you have to remember ionic bond forms between metal and non-metals. Metals re- release electrons or loses electrons to form cations, and non-metals accept electron to form anions. After forming cations and anion, they combine to each other by strong electrostatic force of attraction, and then the bond formed is known as electrovalent or ionic bond. Hmm. Now, what is electrovalent or ionic compound? If or electrovalent bond present in a compound, then the compound is known as electrovalent or ionic compound. So, what is electrovalent or ionic compound? The chemical compounds formed as a result of transfer of electron from one atom of an element to one atom of another element are called ionic or covalent compounds. And electrovalency, what is electrovalency? Electrovalency is the number of electrons that an atom of an element loses or gains to form to form a electrovalent bond is called electrovalency. Okay, electrovalency is the number of electrons that an atom of an element loses or gains to form electrovalent bond is called electrovalency. Now let's say the condition of chemical electrovalent bond formation. I have already told electron forms generally between metals and non-metals. Metal of group 1, 2 and non-metals of 15, 16, 17. Okay. So condition of chemical electrovalent bond formation. First, low ionization potential. We know that metals have low ionization potential. Huh. So in to form electrovalent bond, the one component must have low ionization potential. Second, high electron affinity. We know that non-metals have high electron affinity, that is electron loving. That's why they easily accept electrons. So one component of electrovalent compound must have high electron affinity. Generally non-metals have a high electron affinity. Third point, large electronegativity difference. We know that group 1 2 metals are electropositive element, and group 15 16 17 elements are electronegative element. That is there is a high electronegativity gap or difference between metals and non-metals. Larger the difference between electronegativity of two component, greater is the stability of the ionic bond formed. So more the difference in the electronegativity, more will be the ionic nature of the resulting compound. The metal of group 1, 2 and 13 have tendency to lose their valence electron, so they combine with non-metals of group 15, 16 and 17, which have tendency to gain electrons and form ionic bonds. Here one note given. Note, group 1 elements are most electropositive. They are metallic in nature, and their metallic nature increases down the group. And group 17 elements are most electronegative. Among all the group 17 element, fluorine is the most electronegative element. So fluorine is the most electronegative element, and in case of group 1, cesium is the last element of this group. Cesium is the most electropositive element, and fluorine is most electronegative element. That's why cesium fluoride is the most ionic compound. Okay, so most ionic compound is cesium fluoride. The bonds formed between metals and non-metals are ionic or covalent. I have already told. Now question is, why are ionic compounds are stable? Because in ionic compounds there are oppositely charged ions, that is cations and anions, and the charge are held together by strong intermolecular force of molecular force, that is electrostatic force of attraction. The ions, positively and negatively charged ions, are held together or joined together by a strong electrostatic force of attraction between the opposite charges, which is much higher, and it makes ionic compound stable. So example of ionic compounds: NaCl, MgCl2, CaO, calcium oxide, potassium bromide, KBr, calcium chloride, CaCl2. Now structure of ionic compound. Here it is explained by taking one example of sodium chloride. Sodium chloride, in sodium chloride is the ionic compound in which their sodium and chlorine atoms are present. Uh, We know electronic configuration of sodium is 281 because atomic number is 11. So electronic configuration is 281. That's why sodium atom is not stable. But after losing one electron from sodium atom, it will become Na2 Na plus sodium ion, positively charged sodium ion, which has electronic configuration 2,8, that is valence shell octet field. But in case of sodium atom, the valence shell, in the valence shell there is one electron. That's why this is not stable. Okay, so sodium easily release one electron to form Na plus ion. Here it is a one comparison given between the Na plus and sodium and sodium ion, that is Na plus. So comparison of the properties of sodium atom and sodium ion. Let's see. First, color. Sodium atoms, sil color sodium atom silvery white color, but sodium cation is colorless. Toxicity. Sodium is poisonous, but sodium plus is non-poisonous. Second, chemical action. Sodium very active because they have uh, their valence of sodium atom is not octet field. Okay, there is one electron, extra electron. But in case of sodium plus ion, it is chemically inactive because they have uh, sodium plus ion has a octet field valence orbital, that is 8 electron in valence shell. Valence shell, sodium atom incomplete outermost shell, but sodium plus ion has complete outermost shell. Electrical state, sodium atom electrically neutral, but sodium cation positively charged particle. Okay. Existence, sodium atom exists in combined state, but sodium ion independent existence. Similarly, in case of chlorine atomic number is 17. Electronic configuration is 287. So there are 7 electron in the valence shell of chlorine. So it will become stable after gaining one electron. So Cl easily accept one electron to form Cl minus ion, chloride ion, chlorine atom to chloride ion, which has electronic configuration 288. That is more stable. 8 electrons in the valence shell. So here also comparison between Cl minus and Cl atom. So chlorine atom color yellowish green, but anion, Cl minus anion, is colorless. Toxicity. Second point, toxicity. Chlorine atom poisonous, but chloride ion non-poisonous. Order: chlorine atom suffocating order of chlorine atom, but chloride ion orderless. Chemical reaction: chlorine atom very reactive, but chloride anion inactive. Valence shell: chlorine atom has valence shell incomplete outermost shell. That is there is 7 electron in the valence shell. It will be complete when the number of electrons become 8. And chloride ion has complete outermost shell. Electrical state: chlorine atom electrically neutral, no charge there. In case of chloride ion, electrical charge is negatively charged. And existence: chlorine atom not independent exist. Uh, but chloride ion anion is independently exist. Okay, here now let's see the orbital diagram of NaCl. Orbital structure of NaCl formation of electrovalent bond. So Na sodium atom has extra one electron in their valence shell. That is electronic configuration is 281, and sodium chlorine atom has electronic configuration 287. So sodium atom one uh, easily lose one electron, and chloride atom easily accept one electron from sodium atom. That's why sodium gives one electron to the chlorine atom, uh, and sodium becomes Na plus, and chlorine becomes chloride minus, yeah, Cl minus chloride. So Na plus and Cl minus form, and finally this Na plus and Cl minus will join by electrostatic force of attraction between them. Okay, this orbital diagram, orbital structure in the syllabus, it is not included. Orbital structure of electron different compounds, ionic compounds or covalent compounds. You have to read electron dot structure. This is simple in this method. You have not to draw orbital diagram of element. Here in electron dot structure or Lewis symbol, you have to just write the valence valence electron. You have to show the valence electron by giving dot only. Okay, so valence electron only. Okay. First example, in case of NaCl, sodium has one electron in their valence shell, so sodium dot, and chlorine has seven electron in their valence shell, so Cl and seven dot. Let's see the electrovalent dot structure of NaCl. So Na dot plus Cl 7 dot, and sodium gives one electron, extra electron to Cl minus chlorine, and therefore sodium becomes Na plus and chlorine become chloride Cl minus, and then it both of Na plus and Cl minus will join to form NaCl ionic compound. Second example, MgCl2, magnesium chloride, formation of magnesium chloride. Magnesium electronic configuration is, atomic number is 12, electronic configuration is 282. 282. So magnesium will release or lose 2 electron to become octet. That's why magnesium, after releasing 2 electron, magnesium minus 2 electron, it becomes Mg2 plus, because 2 electron release. So electronic configuration of Mg2 plus is 28, which is stable than magnesium atom, because octet electron in our valence shell. Similarly, chlorine atom has 7 electron in their valence shell. So one chlorine atom will accept one electron to become stable. But in case of magnesium chloride, magnesium released 2 electrons, and these 2 electrons will accept by 2 chlorine atom. That's why it is written 2Cl plus 2 electron. Cl accept 1 electron, 2Cl accept 2 electron to form 2Cl minus ion. 2Cl minus Cl minus ion also stable, because it has 8 electrons in the valence shell. That is electronic configuration is 288. After transferring electron, they join by strong electrostatic force of attraction. Here orbital structure of formation of magnesium chloride given. You can see magnesium atom orbital structure given, electronic configuration is 2 electron in the first cell, in second cell 8 electron, and in third cell 2 electron. And two chlorine atoms also structure given, and each chlorine atom has 7 electron in their valence shell. That is, magnesium will lose 2 electrons. Magnesium will lose 2 electrons to chlorine atom. Okay, or magnesium gives 2 electrons to 2 chlorine atom to form magnesium 2 plus ion and 2 Cl minus ion. Orbital diagram given. For class 10 syllabus, you have to only read the electron dot structure, not orbital structure. Orbital structure is important for class 9. So electron dot structure of magnesium chloride is magnesium 2 electrons in their valence shell, so 2 dot, and each chlorine atom has 7 electron in their valence shell, so 7 dot in around Cl. So each magnesium release gives 2 electrons to 2Cl chlorine atom to form Mg2 plus and 2Cl minus ion. After the formation of this 2 ion Mg2 plus and 2Cl minus ion, this will combine to form MgCl2. Now formation of calcium oxide similarly. Calcium has electronic configuration 2882, that is atomic number 20. So two valence electron in case of calcium, and oxygen, in case of oxygen atomic number is 8. Oxygen has atomic number 8. So oxygen oxygen has atomic number 8. So oxygen easily accept electron configuration of oxygen is 2 6. So oxygen will accept 2 electron more to become octet. So calcium will lose 2 electron, and oxygen will accept these 2 electrons to form calcium 2 plus ion and O2 minus ion. Both are octet field now. Ca2 plus and O2 minus, both octet. So they combine to form CaO. Here electron dot structure: calcium 2 electron in the valence shell, so Ca 2 dot, plus oxygen has 6 electron in their valence shell, so oxygen has oxygen around oxygen O 6 dot given, and each calcium gives 2 electrons to each oxygen, because oxygen will take 2 electrons and calcium will release 2 electrons. So calcium 2 plus and O2 minus will form. After formation of ions, they will combine by electrostatic force of attraction. Now last, redox reaction. What is redox reaction? Redox reaction is the reaction in which both oxidation and reduction reaction take place. Oxidation means removal of electrons, and reduction means gaining of electrons. Okay, in ionic compounds, one component, general metal, release electron, that is metal oxidizes, and non-metals accept electrons, that is non-metals reduces. Okay, so formation of ionic compound is, you can say, is an example of redox reaction. Okay, here one example is given: 2Na plus Cl2 to form 2NaCl. The two step of this reaction is: first, each sodium release one electron, so two sodium 2 electron will lose, and each chlorine atom will accept one electron. So in case of Cl2, two chlorine atom are there, so each chlorine atom accept one electron. So in Cl2, two electron will accept, by Cl2, two electrons will accept to form 2Cl minus ion. So Na 2Na implies 2Na plus 2 electron is an oxidation, and Cl2 plus 2 electron implies 2Cl minus ion is reduction. So formation of NaCl from Na plus and so from sodium atom and chlorine molecule is an example of redox reaction. Thank you.